So we're going to learn or practice more how to use our calculator with this trig. We still need to know our SOHCAHTOA from yesterday. So remember, SO is sine, which is opposite over hypotenuse. COT is cosine, adjacent over hypotenuse. And tangent is the TOA, opposite over adjacent. So we're still going to label our sides. We're still going to be looking at and writing some fractions. In our first example, I'm going to focus just on angle A and those problems. So the hypotenuse is here, and it won't matter. The hypotenuse will not change. But our side opposite will be here, and adjacent will be there for angle A. That should be a quick recap from yesterday. So, sine of angle A is the measurement of the opposite divided by hypotenuse. So it's strictly a 5 over 13. That's it. It's done. You don't have to do any more for now. Going over to, yes, Alex. Yes. Letter D, cosine of A is adjacent over hypotenuse. So that's going to be a 12 over 13. And then tangent is opposite over adjacent, so 5 over 12. And that was pretty much the back of your notes yesterday. Shifting now, we're going to use angle C as our reference angle. So now this is the side opposite, and this is the side adjacent. It's important that you pay attention to what angle you're using. That's going to help you figure out what trig function you need to work with. Letter C asks us to find the cosine, which is adjacent over hypotenuse. So that's a 5 over 13. Letter B asks us to find tangent, which is opposite over adjacent. So that's a 12 over 5. And then sine of angle C is the opposite side divided by the hypotenuse. What you should see, yes, go ahead.
Wait, for the cosine, will it be the same as the opposite
Sine. Yep,
Yeah.
great. That's what I was going to say, so that's perfect. Good connection. Because we're in the same triangle, all we did was switch which angle we were working on, which made our sine and cosines equal to each other because the angle is different. So an angle A and an angle C are different, but we're in the same triangle, so we're going to get those same measures. If you look over here, it happened again. Because we're in the same triangle but looking at different angles.
How come it doesn't happen for the other one though?
Thank you for asking. Tangent is an opposite over adjacent. Sine and cosine stay pretty much the same because they're both divided by the hypotenuse. So the 13 in this case doesn't change. But in tangent, as soon as we switch angles, they become reciprocals of each other. The tangents do. Okay, so that's a quick recap of yesterday's notes and homework. Any specific questions for this first exercise? Fantastic. In the middle of our paper here, it talks us through how to get to degree mode in our calculator. I told you how to do this yesterday, showed you on the calculator. Here is a picture of what your screen should like and step by step. So let's go to our calculators. Press the mode button, and you need the black box around the word degree.
Go where, mode?
Mode. If you've got the black box around the word degree, you're all set. You don't have to do anything with your calculator. If it's not there, go down and over to it and push enter. So once it's in degree mode, it should stay in degree mode. If your batteries run out, or you get some kind of a funky thing happen because your calculator was left in the truck and it got frozen over the weekend, there's a good chance you're going to have to put it back in degree mode. And I'll remind you every day that we're going to degree mode, just to be sure. But this is probably a good one to keep somewhere handy, at least for this week, while you're getting used to all this calculator stuff. Number 2, we're supposed to evaluate sine, cosine, and tangent of a 30-degree angle, and we're supposed to round to the nearest thousandth. So they gave us what our calculator is going to look like. I'm going to go ahead and just show you those. So sine 30, you don't have to close the parentheses. I do because I like things to be finished. Cosine 30,
Is it the same either way?
yes. I'll do tan 30 without closing. Don't close it. It'll still work.
How does this help us?
Great question. You're not going to see it help us a whole lot today, but Wednesday and Thursday, tons of help. Okay? We're kind of building up to it. So, for the cosine and the tangent, we need to round to the nearest thousandth. Do we need to have a conversation about where the thousandths place is?
Can close.
Alex asked me to try without closing it.
Well, I'm gonna close.
Well, you go right ahead.
Yeah, we got the same answer, so I guess it doesn't.
You're right. It doesn't matter, but I like to close it.
The cosine one stays the same.
So, for the thousandths place,
Isn't that 3 numbers after the decimal?
yes, tenths, hundredths, thousandths, this is the place the zero is going to tell us what to do with that 6. So we're going to leave it right alone. Yep. And then for tangent, tenths, hundredths, thousandths place, the 3 will tell the 7 what to do. Okay? So a little bit of rounding needs to be a piece of what you're thinking about. So sine 30 is not going to change. It's going to be a 0.5. Cosine 30, we're going to round that to a 0.866. And tan 30 is 0.557. Those are the easy ones. You have some nice easy ones to start your homework with, strictly using your calculator. If you have a cell phone that has a calculator on it, you may be fortunate enough to have sine, cosine, and tangent. Your cell phone will be in degree mode. You'll have to turn it out of degree mode. Okay? Yeah? What? Okay. If you have one of these smaller calculators that you used back in middle school here, you'll have to be sure it's in degree mode. You'll have to look at the top of the display. If it says GRA or RAD, you are not in degree mode. It needs to say DRG. And on these calculators, it's this button down here just below the on. So you have to look for that. Be sure you're in degree mode, otherwise you're going to get totally different answers. Okay? If you're not sure, bring me the calculator. I'm happy to help you. To the back. So at the top, it asks us to go ahead and do some practice with our calculators. So go ahead, find tangent of 40, cosine of 20, sine of 63, and pay attention to your rounding. Okay. Who has an answer for tangent of 40 degrees? Alex?
Yeah. 0.839.
0.839?
Yep.
Anyone disagree? Okay, great. How about cosine of 20? Bryce?
0.94.
Ooh. Anyone disagree?
No.
Good. Good, your rounding is great. Sine of 63, someone. Tyler?
891. 1.891.
Anyone disagree? Great, neither do I. Perfect. Remember, these decimals really are not decimals. They are the ratio of the two sides of a right triangle. Okay, it still goes back to what we talked about yesterday. We're still comparing two sides. We're just looking at the decimal version of it now. Okay, so number 4. Could this right triangle exist with the given measurements? Great question. I'm going to start by labeling my triangle. I know that this will be the hypotenuse because it's opposite. It's opposite the
Right.
90-degree angle. We don't know its longest side. We have no number there to tell us that it's longer than 4 or 3. So we have to use the right triangle piece of that. Which angle is my reference angle? Never 90 for us. Never. We never use the 90-degree angle to do sine, cosine, or tangent. Those of you who go on in math will, but we don't ever. This is our reference angle, the 40 degrees. So, which side is opposite?
3.
The 3. And which side is adjacent?
4.
Correct. Okay. So, remembering our SOHCAHTOA,
Or what?
SOHCAHTOA, our little shortcut to remember sine, cosine, and tangent. Which of those SOHCAHTOAs will work for opposite and adjacent? Because those are the two sides we have measurements for. Tangent, yep. So we're going to ask our calculator, what is the tangent of 40, and is that equal to 3 divided by 4? Because our angle, tangent of our angle should equal
I don't know.
opposite over adjacent. No?
That's .839.
It is a .839 repeater stuff. Good. What's 3/4 equal to? 0.75 or 3/4. Good. So this is, excuse me, not a right triangle. Those two things should be equal in order for it to be a right triangle. Those two things will be equal in order for it to be a right triangle.
I'm confused.
We're just connecting the what we did on the front with the triangles to what we just did with our calculators. Proving, if you will,
Yeah.
that this and this have to, that the tangent of 40 has to equal 3/4.
No, I'm seeing how you did the triangle.
How I labeled this?
No, how you decided tangent.
Oh, I decided because the only sides I knew anything about were opposite and adjacent. The 3 and the 4 told me. If I had had hypotenuse, then we could have talked about something else. Okay? We'll get more into how to decide tomorrow and Thursday. Okay. This leads us to the question of, what if I want to find the angle? So I want to know, I want to find the angle when I know what the ratio of the sides is. So in other words, kind of working backwards. And if you would take a second and look at your calculators, right above sine, cosine, and tangent, you should see sine to the -1, cosine to the -1, tangent to the -1. This is where your calculator on your cell phone might not be helpful. Depending on how your calculator is set up, you may not have those inverse functions. Okay? So, let me clear some stuff. Let me go back and back, because it thinks that I'm using my marker still. Clear and clear. All right, so if I want to find, in our example number 5, the sine of 1/2. So that means I go second sine to get that -1, the inverse, and I type in 1 divided by 2. And yes, I'm going to close that parenthesis. And when I push enter, it tells me how many degrees the angle was, the reference angle was that I used. Everybody good with those buttons? Okay. Will you draw a small right triangle near this problem? You don't need one for any of this. It's just writing the fractions.
You know what part? A or B?
A, thank you. I'm going to draw mine right in this space, actually. So I know it's a right triangle. I'm going to make this my reference angle. So that means this tells me that I don't know my angle measure, but I do know the side opposite is a 1 and the hypotenuse is a 2. Where did I get that from? Yep, that fraction right there. Sine is opposite over hypotenuse. Sine is opposite over hypotenuse. Could I find, I think Tyler, you were talking about this other side using Pythagorean theorem. I certainly could, we don't have to.
Would it be 3?
No. Okay, so screenshots and evaluate calculator screenshots down below. How do you interpret this answer? 30 is the angle measure. I guess I should put a little degree symbol right there. 30 degrees is the angle measure. That's what that tells us. So if it asks you to find an angle, which again, we're going to spend time in that on Thursday. If it asks you to find the angle, you're going to use that inverse trig function.
When we do quizzes or anything on this, are you going to take off if we don't put a degree sign?
Yep. Okay, number 6. This just has us practice with our calculator. We're going to round our answers to the nearest tenth. So on your handy dandy calculator, it should say tan -1, 5 divided by 2.
Why -1?
Because we need to find the angle measure. Find each angle.
How did you do exercise 5 in the letter A?
Right on my calculator, I did second, and I'll do this one, letter A. Second tangent, 5 divided by 2. And then you push enter, and it's going to give me my angle measure. So you have to round to the nearest tenth.
When you do angle measure, you just do the second or something?
Correct. Angle measure is the second. Tyler, you're right, 68.2 degrees.
Bless you.
Bless you. Bless you.
Oh, Peter.
Cosine equal to 1/2, because I'm a math geek, I know what that is, but what'd you get? 60 degrees. And sine of E is 2/3. I'll have to go to my calculator for that one. I don't have that memorized.
41.8.
Oh, see, that's why I don't have it memorized. Degrees. So I don't want to get marked off. So tonight's homework is all about using your calculator. Take your calculator, your notes, and your homework home with you, so you have all access to all of that. This will be posted in my big campus as well.